Okay, this video is going to cover 12.1a, and today we're going to be learning about binomial probability. A few vocab words that you'll need to know are success. Success is the event that you are looking for. Failure is any other event that is not a success. Permutation and combination comes back from Algebra 1. We talked about, it's been a while probably, but permutation is the number of possible outcomes when order matters, and combination is the number of possible outcomes when order doesn't matter. So a permutation you might use when, like, say you have n number of people and you're picking them r number to win spots, like first, second, third, etc. Then you would have n factorial over n minus r factorial. And then combinations is when order doesn't matter. That's like if you're picking pizza toppings. If you have, n choices and you choose r toppings, it doesn't matter what order you put them in, you're going to get the same pizza. Like sausage, pepperoni, pineapple, pepperoni, sausage, pineapple. It doesn't matter what order you pick them, you're going to end up with the same pizza. So this has less possible outcomes in a combination when order doesn't matter because some of them are the same. They like double up. The formula for that is n factorial over n minus r factorial, and then it has another divided by another r factorial. Now these are formulas that you've learned in the past, and we're going to be using the calculator mostly to do our number of possible outcomes. But if you're curious to where those come from, I encourage you to look them up and check them out. Alright, so today we're going to be focusing on binomial probability. And these outcomes are successes or failures, and the probability of success is always the same. This is one formula you might see. The one that we're going to use is going to match your calculator. We're actually going to change the variable a little bit. Instead of k successes, we're going to say the probability of r successes. And we're going to use r because that matches what you'll see in your calculator. So the probability of r successes, you're going to have the combination of n choose r, and then it's p to the r power and q to the n minus r, where p is the probability of obtaining a success and q is the probability of obtaining a failure. And n is the total possibilities, and r is the number of successes you want. Successes wanted, yes. So that covers our variables. P is the success probability, Q is going to be the failure probability, N is your total probabilities or your total possibles, and R is what you want. So let's look at where you find this first in your calculator. So the probability stuff is under the math button right here on the calculator, on the TI-84 Plus anyway. And then you have to hit the right arrow, go to probability, the third one or the fourth one, and then these are the two buttons you'll use. And we're mostly going to use N choose R. But there you see the factorial button too. So that's where you get these buttons under math. So here's the first example. A sharpshooter takes 8 shots at a target. Over the long term, she hits the target on 70% of her shots. Find the probability that she hits the target exactly 6 times. So the success here that we're looking for is the success is she hits the target. So success would be that she hits the target. And a failure then would be that she misses the target. The probability of success, since she hits the target 70% of the time, the probability of success, that's going to be our P, that's 70%, and that's going to be 0.70 as a decimal. Probability of failure, that will be our Q. So if she hits the target 70% of the time, she's going to miss it 30% of the time. Or you can find that Q is the same thing as 1 minus P, so 1 minus 0.7 is 0.3. So we got our P and our Q. Number of trials, that's our N. Find the probability that she hits exactly 6 times. Oh, she takes 8 shots. So N is 8. And the number of successes, I want to know how she hits it exactly 6 times. So R is 6. So the probability that she will hit it exactly 6 times. I'm going to write out the formula first, and then I'll plug in the numbers. So the formula was N choose R, P to the R, Q to the N minus R. So that's 8 combinations choosing 6. So 8 choose 6. Probability of success was 0.7. And I want 6 of them to be successful. So 0.7 to the 6th. And then N minus R, 8 minus 6, will be 0.3, our failure rate, to the 2nd power. So the exponents always add up to your total number of 8. And it makes sense because I want the 6 to be successful, so 0.7 to the 6th. That leaves 2 to be failures, so the failure rate to the 2nd. And then putting it in your calculator. So 8 choose 6. This is how I put that in my calculator. So I show your key press history. First you have to type in 8. And then you go and you hit math. And then I arrowed over 3 times. And I chose the third option, which was N choose R. And then it brought me back to my home screen. I typed in 6. And then I did times 7 to the 0.7 to the 6th power times 0.3 to the 2nd. And then I hit enter. And this is what it gives me here. As a decimal, it gives me 0.296475. Or approximately 0.2965. And we could say approximately 29, or even rounding it up to a full percent, we could say it's approximately 30%. So if she has a 70% probability of hitting the target, 30% chance that she will hit 6 out of the 8 shots that she takes. So probability tells me 70% chance she'll make the shot. Binomial probability tells me if she takes 8 shots, the probability that she'll hit exactly 6 of them is 30%. So that's what this formula is giving me, those binomial probabilities. At a college, 53% of students receive financial aid. In a random group of 9 students, what is the probability that exactly 5 of them receive financial aid? So at the college, 53% of students receive financial aid. So receiving financial aid is my success. So P will be 0.53 or 53%. So it's 53% success, which means my Q is going to be 47%. If 53 receive it, 47% do not. So 1 minus 0.53 also gives me 0.47. So you can see where I got the success and then failure. So P stands for success, Q stands for failure. I want a group of 9 students, so my N is going to be 9. And what's the probability that exactly 5 of them receive financial aid? So R will equal 5. So then your formula, probability of exactly 5 will be, so you do the combination of 9 that you're choosing 5. Oops. It's the combination of N choose R times, and then it's times P to the R, Q to the N minus R. So I will have 9, choosing 5 of those students. The success rate is 53%, and I want 5 of them to be successful. So the success rate to the 5th power, and the fail rate is 0.47, and that leaves me with 4 to be unsuccessful. So if 5 is successful, 4 is unsuccessful, or 9 minus 5 is 4. So then I put this in my calculator, and I encourage you to pause it and try to get the right answer here. Make sure you're putting in your calculator right. And I got 0.257 or approximately 26%. So even though this college offers or says or maybe advertises that 53% of the students there receive financial aid, if it's a random group of 9 students, the probability that 5 of them, exactly 5, will get financial aid is 26%. So much lower that they will actually receive the financial aid out of that group. So DeAndre Jordan is a career 44.7 free throw shooter. I looked up these stats back in 2018, so he might have gotten a little better. But if he shoots 8 free throws, what is the probability that he makes 5 of them? So when he gets up to the line, there's a 44.7 chance that he's going to make it. But if he shoots 8, what's the probability that he makes 5 of them? So that's where it differs from regular probability and binomial probability. So do you want to follow this guy at the end of the game or not? Do you want him to give him a shot to make those free throws? So the probability of success, or the success, is that he makes the free throw. So the probability that's successful is at 44.7%, which as a decimal will be 0.447. Moving the decimal point 2 to the left there to change that. And then Q is going to be 1 minus the 0.447, which is 0.553, or 55.3% chance that he misses it. I want a total of 8 free throws, and I want to know when he makes the probability of him making 5 of them. So N will be 8, R will be 5. So the probability of exactly 5 be 8 choose 5, or combination of 8 with 5 chosen. And then probability of success is 44.7%. And I want 5 of them to be successful. And if he has 5 that are successful, that means 3 of them would be failures. So 0.4447 to the 5th and 0.553 to the 3rd. And approximating that in my calculator, I got 0.169. which is approximately 17%. Now, if you have a different kind of calculator, like a regular standard calculator, let me see, I'll pull mine up. I'll show you what it might look like. So you would have to look under like your different functions. So I have N choose R here, and it gives me a parenthesis. So then if it is this type of button, then you have to, in your parenthesis, you got to go back to, you would do 8 and then comma 6. That would be 8. Oh, it was supposed to be 8 comma 5. That would be 8 choose 5. 8 total, and you're choosing 5 with how many combinations is that? So there's 56 different combinations, and then that that times 0.447 to the 5th, and then and then that times 0.553 to the 3rd, and you would get, oh, I was supposed to put the answer here from the previous one. There we go. 0.169. So this might be it. The button in the calculator might look like this one instead. So if you have the graphing calculator, though, it's like the picture that I showed you under the math button. I encourage you to pause it and try to get the right answer there so you know you're working the calculator correctly. So what if it doesn't say exactly? What if I wanted to know the probability that he gets at least 5 of the shots out of 8, or he gets at most 5 of the shots out of 8? Then it changes a little bit. So at least means that you need to include every value for successes above that value. So if I say he makes at least 2, then I have to find the probability of 2 plus the probability of 3 plus the probability of 4 plus the probability of 5, all the way up to however many there are. So in the last one, it would have been all the way up to probability of 8. So if he made at least 2 shots. Then there's probability of at most, and at most needs to include every value below the value, because at least means greater than or equal to 2. At most means less than or equal to 4. So at most you would go from 0, 1, 2, 3, 4. So you would add up, you'd find each individual probability and add them up. Now you can do the opposite, so remember that everything adds up to 100%. So say you wanted to do at least 2 and you had those 8 trials. So from 8 trials, if you wanted to do at least 2, you would have to do probability of 2 plus 3 plus probability 4 plus 5, 6, 7, 8. You would have 7 different calculations that you would have to add up. You could do the opposite of that though and do 1 minus the probability. The opposite of greater than or equal to 2 would be less than 2. So then you would do 1 minus the probability of getting 0 plus the probability of getting 1. And then that would be the same thing as the probability of greater than or equal to 2. So sometimes this would be easier to use like the converse of it instead. So let's see what that looks like. A study states 34% of people prefer their eggs scrambled. You randomly select 7 people who had eggs for breakfast. What is the probability that at most 3 of these people prefer scrambled eggs? So at most 3 means less than or equal to 3. So 0 people, 1 person, 2 people, or 3 people. So to find the probability of at most 3, we have to find the probability that 0 people like scrambled eggs, and we have to add it to the probability that 1 person likes scrambled eggs, plus the probability that 2 people like scrambled eggs, plus the probability that 3 people like scrambled eggs, and then add them all up. So the probability that 0 people like scrambled eggs would be, not 0. We have a total of 7 people, so our N is 7. 34% like scrambled eggs, so we're going to say our P is that 34% or 0.34. Our Q then will be 0.66, that's our doesn't like scrambled eggs. N is 7. For each one of these, our R would change. For probability P is 0, R would be 0. Here, R would be 1, R would be 2, R would be 3. N's going to be 7 in all of them. So probability that 0 people like eggs is going to be 7, choose 0. And then it'll be, my success is 0. I want 0 successes, which means it leaves me with 7 failures. And I could calculate that. And then I want probability of 1 person liking scrambled eggs, so that's going to be 7, choose 1. So this time I want 1 success, so 0.34 to the first, and that leaves me 1 success is 6 failures. Probability of 2 people liking scrambled eggs will be 7, choose 2. That's going to be 2 successes, which means I have 5 failures. And then the probability of 3 people liking it will be 7, choose 3. 3 successes, so 0.34 to the third. If 3 people like it, then 4 people don't like it, so 4 failures. Okay, the video kind of closed out on me, so hopefully I can put this back together. I needed P3 again, so 7, choose 3 will be 0.34 to the third, which means that if I have 3 successes, I have 4 failures. I took the time to calculate these values earlier. 7, the probability of 0 people liking it is 0.05455516. Probability of 1 person liking it is 0.196716. 2 people liking scrambled eggs, 0.304016. 4 people, 261024. The total of all of those together will add up to 8162 approximately, 82% chance that if you randomly select 7 people who had eggs, at most 3 of them, so 3 or less, will prefer scrambled eggs. 82% chance that that will happen. Now notice that I kept quite a few decimals in my numbers. You can store these values in your calculator, but just don't round too early. So don't round too early or you will get a value that has too much error in it. Store them or keep them in your calculator and add them up as you go. Try at least 4 decimals to round out to before you get going too far. Now I did say you could do the opposite, so if you wanted, sometimes it makes it less work. This one ends up being about the same. If you wanted to do at most 3, instead of at most 3, you could do the probability of greater than 3 and then do 1 minus that answer and you would get the same thing. So you could do 1 minus greater than 3 would be probability of 4, 5, 6, and 7, and then do 1 minus that, and that would be 1 minus 0.1838, which is the same 0.8162. So this one would be the same amount of work. You'd have to find 4 different probabilities and add them up and then subtract it from 1. But say it was out of 5 instead of out of 7, then you would only have to do probability of 4 and 5 and 1 minus that. So it'd be easier to do it the reverse way or the converse way, the 1 minus it. Okay, questions, let me know. Hopefully the end of this video will go along with the rest and we'll be good to go.